Hi, 8th grade. Welcome to Lesson 5-2, Solving Systems by Graphing. By the end of the lesson, I want you to be able to say, I can find the solution to a system of equations using graphs. Let's explore it. Beth and Dante pass by the library as they walk home using separate straight paths. The point on the graph represents the location of the library. Draw and label lines on the graph to show each possible path to the library. So we're just looking to draw two straight lines. So here could be one. Let's say this is Beth's. And let's draw another one. Let's do, this is Dante's. Write a system of equations that represents the path taken by Beth and Dante. So they just want an equation in the form y equals mx plus b for both people. So let's start with Beth. Remember, we want y equals, we don't know the slope, and we don't know the y-intercept. The easiest one to find is the y-intercept. That's where it crosses the y-axis. So that's at 1. And the slope is rise over run. So for each point, she rises 1 and runs 1. So her slope is 1 over 1, or just 1. For Dante, same thing. We want y equals, we don't know the m, and we don't know the b. Easiest to look, he crosses the y-axis at 4, and we look to see his slope. His is down 1 over 2, down 1 over 2. So that's negative 1 over 2. So now we have two lines, we have the equation, we have it drawn graphically, and we know that they intersect once, so there's one solution. That solution is at the point 2, 3. That's where the library is. What does the point of intersection of the lines represent in this situation? Well, in this situation, that's the library. It's where they both came from. But they go in separate directions because they're going to their homes. All right, example number 1. Lee is choosing a new cell phone plan. How can Lee use the graphs of a system of linear equations to determine when the phone plan costs the same? Which plan should Lee choose? So it costs the same at the solution. The solution is where they intersect. So first we need to write the equation. So company A says it's 20 cents per minute. So that's going to be our slope plus $75 for unlimited data. Then company B says 25 cents per minute plus $70 for unlimited data. So we know that the slopes are different. Since I already see my slopes are different, I know there's one solution. There's going to be one place where they intersect, and that's going to be when the plans cost the same. So when they're graphing, you can see where it intersects at 195, meaning at 100 minutes, the monthly cost will be $95. So if he uses 100 minutes every month, both plans would cost $95. She could choose either plan at that point. If she's spending less than 100 minutes, so somewhere in the red, she should go with company B because it'll be cheaper. If she's spending more than 100 minutes, she should go with company A because it is cheaper then. It all depends on where the line is on the graph. Let's try it. Solve the system by graphing. So they have y equals 3x plus 5 and y equals 2x plus 4. Again, just as a review, since I see my slopes are different, I know there is one solution. That one solution is where the lines intersect. And you can see right here, that point is at negative 1 in the x and 2 in the y. How does the point of intersection of the graphs represent the solution of a system of linear equations? The point of intersection, so that's the ordered pair. The ordered pair makes both equations true. And what that means is if I were to rewrite the equations, y equals 3x plus 5, but instead of putting in y and x, I put in the ordered pair, it would be a true statement. So let's try it. So the first equation, instead of y, I'm going to put 2 equals 3. Instead of the x value, put negative 1 plus 5. Now solving, 2 equals 3 times negative 1 is negative 3 plus 5. Bringing it all down, negative 3 plus 5 is 2. So it's true for the first equation. Now we can try it for the second equation. Again, using the same ordered pair, instead of y, I plug in 2. Instead of x, I put in negative 1 and plus 4. Bring down the 2. 2 times negative 1 is negative 2. Keep bringing the 2 down. Negative 2 plus 4 is 2. And again, it works. So plugging that point in for both equations, both lines, means it's true. Example number 2. Graph a system of equations with no solution. Remember we said parallel lines have no solution. So it says solve the system. Graph the equations of the system to determine the solution. Well, we can graph the first line, y equals x minus 4, because I know my m is 1 and my b is negative 4. So I put a point at negative 4 and my slope is rise 1, run 1, and that's how they got this red line. But the blue line I can't graph yet because I don't know what the slope and the y-intercept is because it is not written in the form y equals mx plus b. So to solve for y, the first thing I want to do, I'm actually going to rewrite this so you can see it better, but 2x minus 2y equals negative 2. Okay, I'm trying to get that y value by itself. So I'm going to work the farthest away from y, subtract 2x on both sides, cancels out on the one side, and we're left with negative 2y equals negative 2x minus 2. Then divide everything by negative 2. So that cancels, and I'm left with y equals 1x plus 1. So that means my slope is 1, and my y-intercept is 1. So looking here, our slopes are the same. So that means there's either no solution or infinite solutions. So I need to look to my y-intercept. My y-intercepts are different, meaning there is no solution. So we could do that just by inspection, or we could then graph it. So we already graphed the first equation. Now we're going to graph this equation. It starts at positive 1, and the slope is 1. So rise 1, run 1. That's how we get the blue line. And then you can see visibly that there is no solution to these systems of equations. Now we're graphing a system of equations with infinitely many solutions. Same thing, this first line, we can graph it already because we can see that the m is 1/2 and the b is 3. Meaning we're going to start at 3. And our slope is 1, rise 1, run 2. Rise 1, run 2. There's where they got the green line from. But this equation, I don't know what my slope or y-intercept is until I get it into the form y equals mx plus b. So I'm trying to solve for y. I need to get everything else away from the y, starting with the farthest away. So I'm going to add 3x to both sides. That cancels. I'm left with 6y equals 3x plus 18. Then divide everything by 6. And I'm got y, because that cancels, equals 3 over 6 is the same thing as 1/2. And 18 divided by 6 is 3. So my slope is 1/2, and my y-intercept is 3. So knowing what we learned last class with inspection, the slopes are the same, the y-intercepts are the same, they are the same equation, so it gets us the same line. But again, we can look, okay, I'm starting at 3, and my slope is 1 over 2, so I rise 1, run 1, rise 1, run 1. Following the same pattern, it's the same line. There are infinitely many solutions. Every number on that line, every ordered pair on that line will work. Try it. Solve each system by graphing and describe the solutions. So we've got 5x plus y equals negative 3. Again, can't do anything until I'm in the form y equals mx plus b. That form is called slope-intercept form because it shows us the slope and it shows us the intercept. So this equation is y equals negative 5x minus 3. So I start at negative 3, and my slope is down 5 over 1. Instead of going down 5 over 1, I'm going to go up 5 to the left 1. So 1, 2, 3, 4, 5. Do that again. Up 5, 1, 2, 3, 4, 5 over 1. Doing it again, 1, 2, 3, 4, 5 over 1. Here is one line. Okay, the next equation. 10x plus 2y equals negative 6. Got to get that slope-intercept form. Slope-intercept form. Slope and intercept. Get everything away from the y. This cancels. 2y equals negative 10x minus 6. Divide by 2. Hey, go Sabres. Y equals negative 5x minus 3. Already by inspection, you should be able to tell how many solutions there are, but let's graph it. My y-intercept is negative 3, and my slope is negative 5. I can always put that over 1, so it's my rise over run. I can go up 5, to the left 1, up 5, to the left 1. There are how many solutions? Infinite. Ooh. All right, let's try B. 1/3 x plus y equals 7. Again, this is not going away, folks. Solving for y. So I'm going to subtract 1/3 x from both sides. This cancels. I get y equals negative 1/3 x plus 7. So I'm going to graph this. My y-intercept is at 7. I'm going to use black, so I'll write this in black. Y equals negative 1/3 x plus 7. So starts at 7. My rise is negative 1, so I'm going to go down 1 and then to the right 3 and continue the pattern. Here's my line. All right, in the next equation, what color haven't I used yet? Let's do green. The next equation is 2x plus 6y equals 12. Our first step, get y alone because we're trying to get the slope-intercept form. So I subtract 2x from both sides. This cancels. I have 6y equals negative 2x plus 12. Last but not least, divide out the 6. This cancels. Y equals negative 2/6 is the same thing as negative 1/3. And 12 divided by 6 is 2. Looking at both of these equations, you should know how many solutions there are, but since they asked us to do it graphically, we are going to do it that way. My y-intercept is 2, so I'm starting at 2. My rise is negative 1, my run is 2. It's the same slope as our black line. Different y-intercepts. They never intersect, so there is no solution. All right, let's look at the key concept. The solution of a system of linear equations is the point of intersection on the lines defined by the equations. So here, they intersect at one point. That point is negative 2, 1. That is the answer. That is the solution. If you just physically see one line, it's because they are right on top of each other. They have infinitely many solutions. All the points along this line will work. Then if the lines are parallel, meaning they never touch, there is no solution. There is no point, no ordered pair that will work for both lines. All right, 8th grade, let's see it. I can find the solution to a system of equations using graphs. Have a super great day.